Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Since the launch of the first weather satellite in 1960, these spacecraft have vastly improved weather forecasting around the world. Weather satellites now provide incredibly detailed images of weather systems, as well as a wealth of data that make those forecasts extremely accurate. They've also gotten much smaller. And my guest on this edition of the Ex Terra Podcast is Dan Harkins, Chief Operating Officer of Tropical Weather Analytics, which is developing a constellation of weather nanosatellites. Dan, welcome to the program.
Thanks for having me, Tom. It's great to be here.
Nice to have you. And I got to say that from the looks of your background, I'm not sure why it's tropical weather analytics, but it looks like it's a little cold and snowy where you are.
That's the end goal, is to control all the nice places where hurricanes happen so I can just move there and go from place to place. This is my penance for now. Just have to stay in New Hampshire.
Well, I've often said to my friends who still live up north that I've never in my life shoveled hot and humid. So, but anyway, tell us a little bit about what Tropical Weather Analytics does.
So we're building small satellites that will improve hurricane forecasts. So we will have at least 12 hours earlier than what the current technology is offering, and about 2 times more accurate. And in addition to this, as we were developing our hurricane technology, which basically measures the winds in 3D at a very high accuracy. So across all altitudes, we get the wind. This is how we get a better hurricane forecast. But really, it's based on the clouds. And so clouds cover 67 to 70% of the Earth at any given time. So getting the wind data out of those clouds is actually a bigger deal because especially the polar vortex and the jet streams, if we get that wind data, we can actually improve the weather forecast quite a bit. And so that's basically the mission of our satellites, is to improve hurricane forecast, but also include your daily weather forecast. And then I would know I have all the snow coming and I could get out of here and not have to deal with it.
And you mentioned hurricanes, and since I do live in Florida, that's a particularly interesting topic to me. But it sounds like what you're going to do is give my local weather forecasters another week or so to try to make us panic before the storm either comes ashore or doesn't. Because as soon as there's the first tropical disturbance out in the middle of the Atlantic, they start saying there's a hurricane coming. Get your hurricane kits together now. And I understand all that because you want to be prepared. Tell us about how this all kind of affects that preparedness piece of the hurricane forecasting.
Well, that's like an interesting psychological thing that I think we really want to help with, is that people either get so scared and hyper aware, and then if something doesn't happen the next time around, they're not as inclined to listen, or they're inclined to wait until the last minute. And I think once you sort of erode that trust a little bit in the forecast, the response of people to evacuate or make preparations is just lessened. And so I know that from our perspective, we'll know a little bit earlier, but really having that certainty over and over again and repeatability and accuracy instead of this. And to a degree, there's a little bit of, in the forecast, a larger cone of uncertainty because they want to hedge their bets. But I think on a psychological aspect, that doesn't work all that well, because then people tend to think, well, maybe it won't happen this time, or it won't happen to me. And this makes them slower to react. So the two things is that a better forecast will, help people, take it more seriously every time. And then also that extra time to get assets and safeguard infrastructure is huge. Even 12 hours can save 30% of costs and damages. But even getting pumps and just shutting down parts of the, figuring out what you can do with the power grid and things like that before they go down, it is just a big deal for that, that forecast and improving that forecast. So we can save a lot of money, save a lot of lives. And especially, when it comes to Florida, that's going to be one of our big places, obviously, because every year something happens.
Something does happen. And it's interesting that you mentioned the cone of uncertainty that they talk about. And that leads me to ask you about how your technology will feed into the various forecasting models. We all look at the spaghetti models when we live here. And we also know that, or feel, because it does seem to always happen, that, okay, today, here's the track they're giving us. let's wait 24 hours and see what tomorrow's track is, because it is going to change. So how are you looking to help improve those spaghetti models to improve that track forecast?
Yeah, so a couple of things is that we'll measure at least 5 times a day.
Mhm.
In the beginning. So maybe there's a certain point we add more satellites and we can get more frequency, but 5 times is actually pretty good. Right now, we want to not take the place, but we will be complementary to the Hurricane Hunter aircraft,
Mhm.
which can only fly so far, so many times. There's mechanical issues. There's all these things that they can't really be there like a satellite can be. And these are huge storms. You know, we take a wind swath about 2,000 kilometers by 2,000 kilometers, and sometimes they're bigger than that. So I think that's the biggest thing is our frequency rate of measuring. And then what also happens is the rapid intensification, which Ian was one of those storms that people were surprised by. And oh no, how did this happen? There's a weird discussion in the meteorology community that it wasn't that they didn't know, but it was the reporting and that sort of, you know, the communication to the public was an issue. But for us, the rapid intensification is really about the vertical wind supercharging that storm.
Mm-hmm.
And nobody's measuring that vertical wind component to the accuracy that we do. The hurricane aircraft come as close as possible because they drop sondes right directly into the storm. But we will basically, like looking inside the cloud, we'll be able to see that vertical wind. So we'll be able to predict those rapid intensifications earlier than what happens before, when they become kind of like a surprise.
You know, you mentioned about measuring the vertical winds. How does a satellite measure wind? What do you base those wind forecasts on?
The pretty interesting part is actually we're optical. So especially when 5G is coming on board, we don't know what's going to happen with satellite observation. Many think that 5G is going to interfere enough to put us back 30 years in forecasting. So a lot of satellites are measuring using radio waves, microwaves, what have you, those types of soundings. Those are proven. Ours is actually optical, in that we fly 2 satellites at a known distance from each other, and these take images and create a stereo effect. So from there, the backscattering, the clouds, everything else, all these cloud features, we actually our algorithm develops a model to figure out what's happening on the inside. And these are just based on the features that we're measuring. Basically, you know, these 2 satellites come at it from a different angle, we composite the pictures together, and that's how it makes a nice image of 3D, but also there's just a ton of numerical data that we can extract from that. And that's how we get the wind. So this will be an important calibration point in the event that 5G actually does interfere with weather observations right now. Ours will not be interfered with because it's a completely optical system. The real brains of what we do is in the modeling and the algorithms that we developed over the course of nearly 20 years of 3D and stereoscopic measurement.
What currently limits us from better forecasts, particularly with these kind of catastrophic weather events?
Well, not having our satellites up, so those have to be up there. That's number one.
Okay.
The second thing is, I think, to a degree, just more satellites. You know, we just saw the European Space Agency has released their report. For a number of years, they've been coming out with how much the Aeolus wind satellite, which just collects wind data. This is a line scan, so it's different than what we do. It's a little bit smaller, doesn't measure as much frequently as we would do. But that satellite itself improved the forecast by 4% and showed a 3.2 billion euro economic impact for, you know, money that it saved and money that other industries could benefit from. So I think collection and more concentration on collecting more wind data, because we do have amazing billions and billions of dollars worth of assets up there, the GO satellites. There's tons of satellites collecting wind data. But the low Earth orbit with the frequency and, you know, not just our measurement tools, but there's other measuring tools that can be used. Those low Earth orbits will really have a huge impact on weather forecasting, because there's going to be a frequency of measurement that we just don't get from the larger satellites, and then a coverage across the globe. So that's really where, you know, our satellites need to be up, but other weather satellites should be in development. And I think on the commercial side, to really cover the globe. We think we have it covered, but as you said about, you know, hurricanes forming off the coast, a lot of that open ocean stuff is just actually really not covered all that much, other than geosats, which are obviously far out. and then you don't see it so many times a day.
So your technology had its origins on the International Space Station. Tell us a little bit about the origin story of what it is you're doing.
Yeah, even before that, actually, we were part of a satellite team. Project Ramos is where this started out. The company at that time was called Visidyne. Our lead is A.T. Stair, and he's actually was the chief researcher and scientist at the Air Force Geophysics Lab. And so Project Ramos was a joint project to develop these large 2,000 kilogram satellites. One would be made by America, one would be made by Russia. This was done to get us to cooperate. So as we were working on the technology behind that and the kind of sensors that would go into it, the 3D modeling was really a big aspect in what Visidyne was really heading up at that time, how to get these stereo measurements of hurricanes. And it was mostly about hurricanes, actually, those satellites. And then we just got along so great with Russia that they decided, we don't need this cooperation anymore. That was never a problem again, so that's good. But sadly, that project, before we actually got into orbit, was canceled. But then what NASA wanted to do was keep going ahead with funding this 3D modeling of hurricanes, because hurricanes was still such a big deal. So that turned into a project where they were basically giving us contracts to develop the 3D modeling technology for a few years. And then it worked out well enough that they said, okay, let's put this on the space station and let's actually test it in space and see how well this works. So then that became the CIMUS project, and that ran for about 5 to 6 years on the space station. And that was basically the astronauts were taking measurements, and then we were, well, not measurements, but they were collecting photograph images of hurricanes. And so through those years of observations and years of storms, we could perfect what we were measuring, understand what we were seeing, because we could check them against other wind measurements, all those kinds of things. And that's where our modeling really came into being and developing the brains of our system. It was on that CIMUS mission. And oddly enough, it worked out great, but it was just, it's not like having two satellites take a picture and being extreme geolocation. It was kind of very coarse type of measurements that we're getting.
Talk a little bit about the satellite constellation you're building, particularly why a nanosatellite? What's the advantage of using a very small satellite as opposed to the larger weather satellites that we're all accustomed to?
Well, one reason why our satellites got smaller is the technology started moving smaller. Right. So they started out as huge 2,000 kilogram satellites was the original project. But one thing that we do need from weather observation right now is we actually need to get a temperature measurement of the ocean from the GO satellite. Mm-hmm. So way back when, our satellite would have been much bigger. Just to get that temperature measurement, it would have been a larger satellite just to get it accurate enough. But with GOES giving us that measurement for free, then we could decide, okay, can we get a little bit smaller here? And then obviously satellite technology started, rapidly accelerating towards smaller and smaller packages. So really, we just use an off-the-shelf bus. We could use anything that's space proven, and we use off-the-shelf space cameras as well. So there's no sensor in there that has to be proven. It was all proven on the space station, and that was just the observation technique so that we could actually collect the data in a way that we can produce these 3D models. And the advantage is these are cheaper. We can put a lot more of them up. And because of their orbit, the frequency and revisit time is a lot higher, as well as just our resolution of wind measurements. Right now, there's about a kilometer scale accuracy. We will be on the 100-meter scale of measuring wind velocities. Something that you can only get right now with an in-situ probe, pretty much with it's on a plane or a weather station.
Are they going to be Agile satellites? Can you steer them? Because you never know where the hurricane's going to form. Will the constellation be big enough that you'll just have something in the area reasonably soon and be able to take those measurements?
Yeah, with our goal right now is just launch our first pair, and that gives us about twice a day across the globe. But our goal is to have 5, and they won't be, right now there's no real plan for propulsion, but I think that's really a price thing because we want to have a deorbit plan, obviously, and then just in case. But there'll be nothing. We'll rely on the orbits, and the frequency will come from the amount of satellites that we have over propulsion getting a satellite into place.
I'm talking with Dan Harkins, Chief Operating Officer of Tropical Weather Analytics on the Ex Terra Podcast. Take a moment right now to click on subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Dan, this is not limited to benefiting the government as far as weather forecasting is concerned. How does it benefit commercial businesses?
Yeah, that would be actually a small component of what we do is selling to the government, and then selling to meteorologists at large. So there's about 300,000 meteorologists across the world that could actually take our data, plug it into a model, integrate it, and put out an end product. One thing that was always important to me was putting weather intelligence directly into a user's hands for a specific application. So we're going to help business in a couple of ways. So that could be commodities trading. If you know what's going to happen tomorrow today, you can certainly play the stock market in a certain way. Commodities like soy, corn, coffee, those types of things that are grown, which comes into another focus that we would be on would be agriculture. So we can help a farmer produce more crop on less land and increase his crop yield just by giving him this missing wind data that he just doesn't have. And the farmer doesn't care about the wind data. All he wants is the weather intelligence in his hands that makes him that allows him to make better decisions and direct his resources in the best way to get the most out of the growing season. So we are developing end-use apps that will put weather intelligence directly into a user's hands. And, we do have those, but it's more about if we integrate our wind data, they will be more accurate, more reliable, and you will be able to see farther in the distance, before some weather event happens. And that's not just, we talk about extreme weather a lot, but extreme weather is, rare,
Fortunately.
Everyday weather makes a difference. And that could be in retail. That can be, again, in agriculture, insurance, energy, especially. One way that we will actually really help the energy sector is certainly because we measure the clouds. So we will always give the best cloud forecast going. So this can help with wind farms. It can help with solar, but also for hurricanes. What's really interesting is there are all these assets just in the Gulf Coast. Across the world, there are some too, but just in the Gulf Coast, when a hurricane is spinning up, they have to decide, do we need to shut down this plant? And this costs the, Exxon, BP, any of these companies with assets there in the Gulf, it costs them hundreds of millions of dollars if they are wrong and they shut down and then the hurricane is, nowhere near close. So for, commercial business, we can really protect those assets to a higher degree and let them know earlier what's going to happen. One cool thing is that the cloud height and the cloud growth in the vertical axis is something that we measure and will measure most accurately. It's basically a rough idea of how much precipitation is going to be in there. So it's not just about hurricanes coming for these assets in the Gulf region. It could be a lot of wind and a lot of rain that creates storm surges and things like that. So by having that amount of precipitation, we might be able to help there too, to protect those and save them hundreds of millions of dollars a year when they don't have to shut down, or if they need to shut down earlier, and prevent spills or any catastrophes that way.
I can think of, as somebody who learned to fly airplanes at a very young age, I think about aviation, and you always check the winds aloft forecast. Because the winds at 3,000 feet can be very different than the winds at 7,000 feet. And I can see where that could be a great benefit to the aviation community in terms of time en route, fuel savings, all of those things.
Yeah, especially weather is always about small changes having big impacts. And aviation is one of those businesses for sure, where if you just make small little changes and save just a little bit of gas because there's so many flights, it goes a long way. So certainly we're going to help aviation a lot, commercial aviation as well as military, because those jet streams are, with climate change and the increase of the temperatures, actually, the jet streams are getting a little strange, and they might get, it might get worse. So clear air turbulence, and just, we don't really know what's going to happen. So that's going to be a big gap that we fill in with our wind data. And right now there's, I think, just twice a day, there are 4 areas and regions where they release the weather balloons to get those altitudes. but they're certainly not at the resolution, not the frequency that we'll be delivering. And the fun thing is, they call it Santa's shortcut is going over the North Pole. Right now, it's kind of limited because of safety concerns and what's being observed. So we think we can open up Santa's shortcut to more direct flights that fly right over the North Pole. Of course, that comes with other problems, because if we open up that channel and then there's a lot of commercial air going over the North Pole, does this accelerate some of the bad things that are happening at the North Pole and make it melt faster? Yeah, so there's a lot of strange things. So we want to open that up, but hopefully we can do it in a way that's safe.
Does that also filter down to the private pilot or the business pilot who sits down at a terminal at the airport and gets his weather briefing or her weather briefing? And will your data be available in those scenarios as well, or are you thinking just about commercial aviation?
No, it certainly would be. We would see it as a service because we can actually disseminate our information really quickly and directly to the user based on programs that are already built for weather forecasting. So it goes back to just like the farmer or just like the stock trader. They won't necessarily know that it's our wind data powering their better forecast, but they'll want to use it because it's more reliable, more accurate. Right now, what I see, oddly enough, there's a couple of commercial weather companies, and I was, seeing the inside of their terminal, what they're doing and using to decide on their routes. And they had 3 different weather services, pulled in. So which one's the best one? Why they have them all? They're spending all money for all 3 of them. And I thought, well, that stinks if I'm in that business, because there's no differentiation and they're just buying everybody's data. So I can't really capture a market that way. So our data will be kind of like that, in that hopefully we become the only choice. So you may have 3 choices now, but when we get in there and have our wind data coming in, there's no reason to use the other ones because there's a better forecast.
Dan, talk about your background just a little bit and tell us about who else is on your team there.
Yeah, so I started out developing biophysics instruments for life sciences for years and years. Some of them actually went to space. So I got really interested in small satellites early on and always wanted to get into this industry. So once 16 years or so of developing those instruments, I actually landed at a company that was building small satellites and was kind of ahead of the curve in my estimation of what was trying to be done, and almost too early because the commercialization of bigger satellite buses and mission-specific buses was where they're headed. So from there, I was their marketing director, and then this opportunity came across. Was always on the side of judging whether a satellite constellation could make money or whether it was technologically viable. Because if we're building that satellite, so I was on the building side of the satellites for about 6-7 years before this. And, there's always the idea of, what's the economic impact of the satellite? Can they pay their bills? Because if I build 1 satellite, okay, but if I'm building 10, it's quite a different price. Can they afford the 10? So I was always on the analyzing the space mission side. And then when this project came across, I said, okay, this is something that makes direct impact, saves lives, saves, billions of dollars a year. And somebody already spent $200 million to fund the technology. So, this is easy. Let me get in there and commercialize this. So 3 years in, we're still trying to commercialize this. We can commercialize, but we still need to get to space. And so I'm leading that effort of the fundraising side. And then our other directors, Ilya Schiller, who's from MIT. I think he's got his master's in mathematics, but he's actually very similar to me, an entrepreneur, marketing and sales, how to, develop a business model and actually bring it to market. So that's one of his expertise. And then A.T. Stair is our president, but he, as I said, he was with the chief researcher of the Air Force Geophysics Lab, and he's been with this mission since the beginning, since the Project Ramos days until it's become this small satellite now. And then our lead scientist is Drew LePage, and he's was basically oversaw the CIMUS mission for us when that was up on the space station.
I'm going to come back to the financing just a little bit, because you've recently had a couple of rounds of funding utilizing crowdfunding. How was that experience for you? Yeah,
so we had worked with Space Ventures to get the crowdfunding. And that was really an interesting project for me because it was pretty intensive as far as reaching out directly to people. And it was, for me, a huge success because gave us extra capital that we could actually put into developing more of our business plan, more of how we're going to get to space. And we know how we'll get to space, but we actually have to fund that. So some portion of that went to, us trying to get our mission to the next stage before we can, get into production of the satellites. So I really enjoyed the crowdfunding. I would say I would recommend it to any, young company that's really just trying to get a foothold. It sharpens your messaging. It sharpens, just the things that you will hear back from potential investors really help you develop your business case and your go-to-market strategy. And it was just overall, it was kind of fun.
How does that work for a company like yours, though? Because normally you see crowdfunding as well. Get in on this early round, and we'll send you this Wheezy widget, or you'll get the first, version of whatever it is that we build as your reward for being in part of the early funding. So how does crowdfunding work for a service like yours?
Yeah, what was different about this and why I liked it so much is at the end of the day, we're not just giving out, a T-shirt for somebody giving us money. They actually own a percentage of the stock, and it's an investment for them. So that was maybe the biggest thing for me to get over, because I thought about crowdfunding before. I said, well, I don't really want to do that because I feel like the people that actually give the money don't get to share in the benefits of the business end. They just get to see this, maybe it's a cool technology or whatever happen. That's great, but they don't really own a piece of it. So this being an investment crowdfunding platform was really interesting to me because people can believe in us and, see us as a way to make money as well as supporting the mission. So, when we're $1 billion company, they'll be able to say, all right, I did that.
I remember you when.
Exactly. And, we have to check their bank account and be happy with that too.
That's always a good goal. But right now, we're looking at a potential serious downturn in the global economy. And so I'm going to ask if you think that space tech startups are going to have maybe a harder time getting financing in the next couple of years or maybe longer, or is space tech kind of immune from those current market conditions?
I think last year was actually a tough year as far as when I was talking to people. And everything that I've heard so far going into this year was actually pretty positive, that there would be, last year was tough and a lot of VCs were just simply not writing checks, which was hard for us because it was not knowing, we only have limited time that we can be pitching and talking with people. And if someone's not really serious about investing right now, that just kind of takes up our bandwidth and, so it's not great. But now I keep hearing that, well, that part is over. It was a little rocky. And now the people that you're talking to now are probably more likely to be writing checks again. So I think that there's going to be a general upturn as far as that goes. But I think space is not necessarily impacted by that because there's so much that can happen. There's so much potential that people want to get into it. So I think we still saw a lot of funding going into space companies last year. I haven't seen if it was up or down, but to me, just from seeing my timeline and people that I know getting funded, it seems like it wasn't really impacted. And I don't know that it's a unicorn or, that it will never be impacted, because when I look at this landscape, to me, I look at it as some of the people that were earlier companies in this. Are they making money yet? And why aren't they making money? And do I want to invest in more space companies that are really expensive? And I still haven't seen a profit from those, earlier companies. So I think that's kind of an interesting aspect. And I think of it that way, but I think for the most part with space, VCs just want the next best thing, the next technology, and are willing to jump on there. And they maybe don't look at it through the lens that I look at it of, well, that company over there has been around for 5 years, and shouldn't they be, they've been commercializing, shouldn't they be a little bit further ahead? But on that note, I think because things are getting so the infrastructure that you need to go to space now, it keeps going down. I mean, I thought it was 7 years ago. I was like, whoa, it doesn't cost anything to get into space. And now, I mean, our launch cost on the first satellite that I was part of was about $3 million for the launch. If that was going to happen today, you'd probably spend about $400,000.
Wow.
And the prices are just crashing because there's a lot more launch providers, and there's going to be more launch providers. Some of the ones that got funded last year were launch providers. So I was like, how many companies do we need? I always think. But with 24,000 satellites about to be, the demand that supposedly is there for 24,000 satellites over the next 10 years, I think that that's actually accurate. So there's going to be plenty of money in launching these satellites for sure.
Which kind of leads me very nicely into my last question, because we are just about out of time, but we do this with all of our guests and ask them to look into their crystal balls at about 10 to 15 years in the realm of space commerce and tell me what you see.
Well, what I want to see certainly is using space to help humanity a little bit better and solving the problems that we're having. I know that some people always say this phrase is that to save the planet, you got to leave the planet. No, I don't think people leaving the planet is the answer, but I do think us observing from space to solve challenges is number one and paramount. So I want to see a lot more technologies and hope that will happen, that will improve weather forecasting and just improve, any other aspect and just, our lives as a whole and going forward as a civilization. And I actually what I see in the future, though, is that companies are going to have a space strategy. So we think about companies that are just going to buy data from these providers, whether that's imagery, my weather data, whatever. But I think if I'm an insurance company, or if I'm an oil company, or if I'm a trading company, I would actually, or a company like Amazon, which Amazon is launching their own constellation of satellites, but all these companies, UPS, FedEx, they could benefit from having their own constellation, running their own satellites. So I think industries really need to wake up and have a space strategy if you're a Fortune 500 company, and figure out, space is not that expensive of an investment as it used to be. And to solve your particular business challenges and to control that, the data that you're getting and collecting is a huge advantage in any industry. So I think that these companies will need to have a space strategy to get their own satellites that solve specific problems to them, not just making a piecemeal and taking pieces of what satellites are offering, but actually tailoring a mission to their business needs.
I'm going to have to leave it there. Dan Harkins is Chief Operating Officer of Tropical Weather Analytics. Dan, thanks so much for being with me today.
Thank you so much, Tom. I appreciate it.
That is going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo through his looking glass. That's for reason. Our dreamer's eyes we gaze into a sense of purpose known by few. Like finding water on the moon.